In the previous part, we say that stochastic gradient descent, or SGD, is much faster than gradient descent, and it can achieve similar performance as gradient descent. And here, let's compare them on a real-world data set to see if this is true. And the example task here is text categorization. And here we have a real-world data set called routers RCD1, and it's a document corpus. And the task here is basically to predict a category of a given document. So it's a one versus the rest classification. You can think of it as a simple binary classification. For example, you want to predict whether an article is about sports or it's about politics. So in this data set, we have about 781,000 training examples or documents, and we have 23,000 test examples. And for each data point, we have as many as 50,000 features. So this is a lot of features for each data point. And basically, it's one feature per word. And we already removed the stop words, and we remove all the low frequency words. Now, the questions that we want to ask are the following. The first question is SGD successful at minimizing the objective function? So this is about the training loss. And the second question is, how quickly does SGD find minimization of the objective function? And the third question is, what's the error on a test set? So basically, how is the generalization ability? And let's look at these results here. So these basically shows some results from 3 different methods. The first one is a SVM solver. And the second one is a SVM that use the gradient descent method. And the third one is SVM that use SGD, or stochastic gradient descent. We can see that for the first question, is SGD successful at minimizing the objective function? The answer is yes. If we look at the second column, we can see that the value, basically the final value of the objective function is very close to each other. So we can say that this SGD SVM is actually successful at minimizing the value of the objective function. For the second question, how quickly does SGD find a minimum? And we can look at this by examining the first column of the results. We can see that for the SVM solver, it takes about 23,000 seconds. So this is very slow. For the gradient descent SVM that we implement, it takes about 66 seconds. And for the SGD SVM, it takes only 1.4 seconds. So we can see that this is that SGD version is actually more than 10 times faster than the original version. So it's actually super fast. And for the third question, what's the error on the test? We can look at the last column. Here we can see that the test error more or less the same, right? It's very close to each other. So we can say that the SGD SVM, the test set error is comparable to the other 2 methods.